Welcome to Explore Labs, and this is the first video on PCB design. This is basically a quick starter video on KiCad PCB Design software. Now this is an open source software which is free. There are no constraints of size, and the most important part is even the entire software is open source. It means you could write your own scripts, and you can design your PCBs to whatever length or whatever dimensions you wish. There are no restrictions at all, and the website is to download the software is www.kicad-pcb.org. Let us just have a look at it. Now this is the website, and it says that you could use it for professional schematics and PCBs. Now on this page you could see here is an option where you can go ahead and download the software, and there is also a fair amount of written documentation which you could go through. And the most important is this. I mean, if you could help develop KiCad, you can visit here. So let's just go down and see an interesting picture here. It shows as to the amount of time spent and the maturity of the software. So if you could see, here is a comparison of the other three softwares. The one in blue is KiCad, and you can see it is it has almost 750k lines of code. It seems good. And here's one more picture which says it is from Google Trends, and it shows how many times it has been used. So I think it is sufficient for you to to get motivated and get started with KiCad. And I hope so you have already wanted to design a PCB using KiCad. So in this first video, it's a quick tutorial. We'll go ahead and draw the schematic, and we'll match the components and then draw a simple PCB. We want to keep it as simple as possible, because this video, it's just a quick starter video, and we'll go ahead and design a simple LED breakout. Okay, so let me just draw a schematic here. So our board, let's say, will have 4 LEDs, and as we know, each LED needs it's a small resistor in order to limit the current. So let's put a LED here, and then this is small resistor, limiting resistor. So let's say this is the input pin, and this we are going to drive it from a microcontroller, and this is LED 1, let me say it as D1, and this is the resistor R1. So we have 4 such LEDs and 4 such resistors. So let's say this is the schematic: R1, R2, R3, and we will also have R4, and these are the LEDs: D2, D3, and D4. Now KiCad takes LED. Now there are 2 things to it. Now this is a component. Obviously it's a LED, and this LED has 2 parameters. So one is the value and the other is the reference. Now what we denote here is the reference. So now reference is like D1, D2, etc., and the value is actual value of the LED. So it could be a 5 mm LED, or it could be a 3 mm LED. So usually you denote either a parameter like resistance, inductance, capacitance, or the package. Usually the value is something which is written in another field. So it will have 2 parameters. One is the reference and the other is the value. value of the component. So in our small PCB we have four LEDs and 4 resistors. Now since everything should be connected, what we plan to do is these will be powered from microcontroller. I mean, these will be driven from microcontroller pins, and hence we have these 4 inputs, and also we need to have a common ground with the microcontroller board or whatever other board that this breakout will be using with. Now, so this is the common ground, and instead of drawing a symbol, I'll just draw it as a pin on the board. So let's say these are the 5 headers that we need to have on a board. So as we have it here on the picture below, so X and Y are the dimensions, and these are, say, the 4 LEDs, these are the 4 resistors, and this is the male or female header that we want on a board. And we'll look through the exact dimensions as we go ahead and design a PCB. So let's get started. So if you have installed the software, and if you go ahead and open it up, it just looks like this. Okay, this is the basic window of the KiCad. So what we have here is, this left pane will show you the list of files that are open, and on the what are the files under this particular project, and these are the tools, the separate tools. Now KiCad uses a different approach. I mean, there is a schematic drawing tool, and there is an intermediate tool to match those schematic symbols with the actual footprints. So as you can see in the icon here, it shows that this particular schematic symbol will be matched with this particular footprint. So it has a schematic drawing tool, that's eSchema, and it has a component to footprint, a matching tool, which is CVPCB, and then you have the PCB editor. This is where you draw the layout of the PCB. And then again, if you generate Gerbers from KiCad or any other software, basically Gerbers are the final files that are sent for fabrication, and if you have done those, you can view it using the Gerb view. So I mean, Gerbers are industry standard, and Gerbers generated by any other software or KiCad itself can be seen with this. Now this is another interesting tool, and this is to create a logo out of an image. So this is if you need to put logos on your PCBs, we can use this. And then this is a PCB calculator. Here you can calculate the track width and a whole lot of other parameters. But let's see, since the task at hand is very simple, it's just a 4 LED breakout board, we'll start out with the schematic drawing. Now let me just bring that up. So here is the schematic drawing software. It says that this is not found. LED 4 LED array.sch is not found. So this is for a new project, so it will not be there. So just click OK, and let me just bring the full window in here. Yes, alright. So on the top you have all the menus, and the most important thing is, let me just bring that up. So these are the hotkeys. So these will come pretty handy when you design. You could always choose an option from the menus, but this is just more intuitive. Like say to add a component, you use shortcut A on the keyboard, then to rotate an item you click R, to mirror it on X-axis you use X, and then to mirror it on Y-axis you use mirror on Y. Alright, and So these are just the shortcut keys which will come in handy. Anyways, we'll in the starting we'll just use the keys on the menu bar here. So we have a simple task here to draw a schematic of 4 LEDs and 4 resistors. So let's just get started. So here is an option to place the schematic. When you tend to use the shortcuts, you kind of forget the menu bar here. So let me just find out where it is. So to place a component, here it is. So to place a component, we just click on it and then click here. Now here again you can select from browse from the library, or you could list all the components. Let's just say we need a LED, so I'll type in LED, and here we have an LED. So here is a LED, then I need a resistor, so let me just type R, and okay, so these are the two components. And to place a wire, you just need to click here, or you could use the shortcut W for that. And then here we have a wire, and I'll make 4 instances of it. You need to select it, drag it, and then right click. So I'll copy this block and I'll place it here. Again I'll copy it and I'll place it here. Sorry, so I did drag but I did not copy it, so let me just do it. So here we go. So this is our small schematic, and we need a pin array. So let me just try and search it. So this is pin, there's no component it says, so let's just select by browsing it. So here we go. So this is the library browser. Now it is a discrete device, or it could be in the connectors, and what we need is 1 cross 5 connector. So we have 5 pins as 5 headers. So here we have 1 cross let me just check, 2, yes, so we need a 5-pin connector. So here is it. So let me put the 5-pin connector, and here is the connector. So we need to route it. So if you place W again, then you can place a wire here, and this is the connection. Sorry. Okay. So this is connection that we need. This is the last connection, and let's say the first pin is a ground pin. So let us tie all the other ends from the resistors to the ground pin. Alright, so here is our schematic, and if you want to denote the ground pin, you could also place a symbol for ground, and here is it. Alright, so so this is the basic schematic, and now we need to, as I said in the beginning, there are 2 parts to it. One is the reference and one is the value. So value, let us just say that these are LEDs, and the current limiting resistor, you could edit the value. Usually you put about 470 ohms to a 5 volts power supply, so so that it is close to about 500 volts, 500 ohms. It would give about 10 milliamperes of current. So this is just fine for an LED. So let's say it's for 70 ohms of resistance, and all these are again of the same value. In fact, we could put the value in the beginning and then copy the resistors to save a little time. So anyways, let me just put all the values here. Now there's a question mark remaining on all the components. This is the reference number, or if we have 4 LEDs or 4 diodes, then these should be numbered, so every component should be unique. In order to do that, you also have a tool here, or an option, which will automatically assign numbers or reference numbers to these pins. So this is the annotation tool. So this is the annotation tool. It will just put the numbers to the components, and you could always sort the components by X position. It will number it in this way, or you could do it in Y position. So let's just keep the default and then click on annotation. So it will just give you a warning in case you are changing in between. It could have implications on the design. So let's just do it and then close it. So now we have the numbers here for the LEDs as well as the resistors. So these are the 4 LEDs and the 4 resistors, and we have a connector. Now in this particular step, or the schematic drawing, we are not assigned any footprint to the schematic. So this is the second step, or the second tool that we discussed. This is CVPCB. This is what we use to assign the components the respective footprints. But before we go ahead and do that, this is the important step of creating a netlist. It is basically a list of interconnection, or the nets which tell the connections between various components in the schematic. So we'll have a detailed look when we go ahead and route the board, but let's just create it. Here's the option to create the netlist, and you could again take this netlist and draw your PCB in any of the other softwares, but since we are going to do it in PCB new that comes along with KiCad, let's just keep the default format and create a netlist and save it. It is a .NET file. That's a netlist. Let me just save that file, and we'll go ahead and match the components. So here is the here is it will give you a list of let me just resize the window here. Okay, so here we go. So on one side you have all the references, and here you have values in the other column, and there's one more list. Now this is the list of components in the library, or you could add your custom libraries. So this is the list of all the components in the library. So the first component is D1, that is LED. So let's say we are putting a 5 mm LED. So let me just search for an LED here. So this is a 5 mm LED. So here you have a marking in front of LED. It means a 5 mm LED has been assigned. If you just in case need to see how it looks, here is the view for it. Here is the 5 mm LED which we are going to assign. You could also see the 3D for that if it is assigned. Here is the 3D view for that LED. Alright, so let's just go ahead and we'll see this while routing again the nice 3Ds of all the components and the complete board. So let's just go ahead and place the LED here. So the LED has been matched. Again, we need the same component for the remaining 3 LEDs. So let me just assign those. Okay, so here we need a 5-pin header, and let me just go ahead and put a 5-pin header here. It's SIL5 SIL, and then a simple resistor, say R4. Now all these resistors, they have different lengths, so you could always measure them here and then you could use them in case you want to know the exact size or the dimensions of the resistor. Now that by default it is in inches or mils. You can change it to mm. Inches is used for its own reasons, like most of the components have dimensions that are whole numbers when you measure them in mils or inches. By the way, inch is about inch is about 1000 mils. Inch is about 1000 mils. So this is inch, and we can assign the resistor now. We can go ahead and assign the resistor in the PCB. So here is the list of components with all the matching footprints. Now let me just go ahead and save it. And now if we now the same netlist file will get updated with the footprints assigned to the respective symbols. So the next step, now to draw the actual layout, we use PCB new, the PCB editor. So if you click on it, it just opens up, and then it will give you a message saying that this is does not exist and it's normal for a new project. So click on OK, and then alright, so here is the window for the PCB editor. Now again, these are all the options or shortcuts. You have also hotkeys even for this tool. So again, to check the hotkeys, you can go and help, and then basically the same hotkeys are used even here. So let's just go ahead and read the netlist that we had created. So we'll just browse the netlist file, and it would be in the same folder as we did our PCB. So this .ned file, and you select it and then read it. Now if all the components are there in the library, then you'll not get any kind of error messages. You should be very careful here. If some component is not present in the library, then it would throw up an error here, or even if there is some sort of mismatch in the components, it would throw up an error here. So we have read the netlist, and these are all the components. They're grouped together, and in order to separate them, you could manually pick the component, press the M key shortcut to move it, and then you can place it here. But there is one more option, because the size of components go up with the number of components. I mean the number goes very up. So let's just draw a layout or an outline, because in order to move these, we need to have a fixed boundary or dimensions for this for the PCB. Here we'll draw the edges using this particular option here. Now these are all the layers that we're going to use on the PCB. Now I've chosen a simple 2-layer board. In fact, we'll do a single layer board because there are hardly any components. So these are the front layer, then the back layer, and all the other options. This silk is for writing texts on your PCBs, so it could be on front side or on the back side, and these are various other options. We'll see them as we use. So let it just spread out the components, and before we do that, let's go ahead and draw edge for the PCB. Now I'm changing the dimensions to mm. Let's say our PCB is about some 40 mm by 40 mm. So like 130 on x-axis, and then I'll move about. What you want is 40 mm. So I'll just start from 130 and it'll go till 170, and the y-axis is 45, so it should be about 75. So let's just see that this is the size of PCB that we need, and So to move the components to this particular edge, we have an option here which says footprint mode. So you can automatically place the components. To place it in the footprint mode, button should be turned on, and then you right click here, right click here, and then you have global move and place. So you can move all the models with this command. So it will just ask, so it's confirmation, so it will just throw up all the components, and these are separated. Now we need to arrange as required. So now let me just change the grid again to mils, because all the component dimensions should be in mils. So let me just change it, and let me select it to be about 25 mils. So here we have, so this is our ground pin, and say these are the 4 registers. Now you could hide the values here so that you can have clear view of the references. So hide text would hide the values of the components. Now let me just arrange them. You can rotate it by hitting R, and then likewise you can go ahead and arrange the remaining components. Alright, so here we have arranged all the components. Now the lines that you see on the right, these are called the rat nest. It will just show you what should be connected where, and the netlist, it will just number the connections, like N8 will be connected to N8 on the other component. So this will highlight as to what connections or what is the routing that needs to be done. Now since we want a particular form factor, like say these are the inputs, these are the resistors, and these are the LEDs, we have crossovers. Usually we try and avoid and place it in a way that there are no crossovers. We could do that, but we have in fact already drawn our schematic. We could go ahead and change. We could change these LEDs to we could just swap the position of LEDs and resistors so that we can arrange, and we can go ahead and make a single layer board. But here, since we already done it, let's just go ahead and route the board, and you could try and arrange it and do just a single layer board. So now to route it, just click on layer, and I'm using the tracks at the back. And now again, the default track size is about 0.2 mm. So usually the unit is just mils, and if you go ahead and calculate it using the calculator, this is just a LED, so the track width, let me just say it is about 25 mils. So let me just change or add a new track width. This is 25 mils, and if I think this would be enough for this project. So let me just go ahead and route, and to route you select the layer. Here I'm routing on back, and then you select the track. So and you just proceed according to the netlist. And before I do that, let me just select the track size, custom track size, and then I'll go ahead and route the board. Now this is a basic route, and then you see these connections overlapping, so you might have to use jumpers or a different layer. So let's just go to the second layer, and let me just connect this, all the ground pins, and this is the ground. So this is the basic route. Now in order to, you could use ground field uh, for this, for the stability of the circuit. So to put a ground field, you just click on this option, add field zones, and then you draw an outline for the zone. So this is a ground layer, and I'm doing it on say the top layer. I should go ahead and draw the perimeter here, and right, so here we have our ground field. So right click on it and then just click on fill or unfill zone. So this is how we have a fill zone on top side. Now it's time to see the 3D view of the PCB. So click on view 3D, and here we have a 3D view of the board. So again, you can put some labels here, and then you see the routing on the back side. So this is 3D view of the PCB. Now to go ahead and get this PCB fabricated, you need to generate the Gerber files, and to do that it's pretty simple. Click on file and then go to fabrication, or you could click on plot, and then you can select the layers that you need, and it's front for front tracks, then back for back, and then the silk is the labels on the front side, and usually you have them in front. So let's just say front and then say plot. So the respective files will be plotted in the area you have the project, and you can see in the same to your fabrication plant. Thanks for watching.